Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, bottom view of binary tree. So what the problem is saying is, we'll be given a binary tree, okay, and we want to return the elements, okay, which are visible in the bottom view of the binary tree. So when we say bottom view, right, so we'll have to look towards this direction, okay, towards this direction that is from the bottom, okay. So in order to view the elements which are going to be viewed in the bottom view of the tree. So first we need to let's mark the vertical distance, okay, in order to see which elements will be visible, okay. So here if you see this is a second vertical line, then this is a third vertical line, right? This is a third vertical line, and this is the fourth vertical line. So if we look from the bottom, right, so which elements are going to be visible? So one is going to be 40, right? Then for another vertical line it is going to be 20, right? If you look at this vertical line, this 60 is visible and it is hiding 10. Okay. So from bottom view, the element which is going to be visible, it is going to be 60. Okay. And then we have 30. Okay. So this is the bottom view. Okay. The elements which are visible from the bottom view of the binary tree. So we want to return these elements. Okay. So this is the ask. Okay. Now how can we solve this problem? Okay. How can we solve this problem? Now what we can do is in order to have the elements of the bottom view, what we can do is we will use the concept of horizontal distance. Okay. So what we're going to do, so for example, for this root, it is going to be HD, the horizontal, it is going to be 0. So as we go to the left, we will decrement this HD minus 1, this horizontal distance by 1. If we go to the right, we are going to increment this the horizontal distance by plus 1. Okay, increment by 1. Okay, so now for example, if we go down to 20, so what is the horizontal distance be? It is going to minus 1. If we go further left, it is going to be minus 1, which is going to be minus 2. If we go to the right, it is going to minus 1, right? Minus 1 plus 1, right? HD plus 1 we need to do. So when we go to the right, we need to increment the horizontal distance by 1. So we're going to increment, it is going to be 0, right? So HD is going to be 0 here, right? Now let me write it properly. So here it is going to be 0. Now if we go here from 10 to 20, 30, right, towards the right, so it is the HD is going to be 1 over here. The HD is going to be 1 over here. So once we have the horizontal distance, what we're going to do, we are going to have a map. Okay, a map. We are going to use tree map basically. Okay, okay. So what the map will be? The horizontal distance and the node value. Okay, the node value. Okay, so let's see. So for example, right? So first of all, what we are going to do when we start from the root, right? So we are going to insert this horizontal distance of the root, right? That is 0 and with the node value is 10. Okay, then we go to the left, right? So we are going to insert this horizontal distance minus 1 and we'll have the node value is 20. We go further left, right? It is going to be minus 2 and 40, right? Then we go to the right, the horizontal distance is 0. So what we are going to do, we already have the 0th element, right? 0 as a key. So we're going to override. We are going to override this 10 with 60. Okay, we are going to override with 10 with 60. Okay, then we go to the right of this, right? So what we're going to do, 1 comma 1 comma 30. Okay, 1 comma 30. So here we are going to use tree map because we want this horizontal distance in the sorted format, right? We want this horizontal distance in, and as you know, right, in the tree map, right, when you print the elements, so this, or when you iterate to the elements, so this is going to be in the sorted way. Okay, so now what the value, so how it is going to look like in the tree map, it is going to store like this, right? So minus 2, 40, then minus 1, right? This is going to be in sorted form. Minus 1, 20, then 0, it comes 0, which will be 60, and 1 as 30. So when we iterate through this, we are going to iterate through this map, okay, and we are going to fetch out the values, fetch out the node values, right? So minus 2 will be getting, whose node value is 40, right? Then 20, then 60, and then 30, right? Minus 1, minus 2, minus 1, 0, and we have taken the node values. Okay, and this will be the final answer. Okay, if you see this 6, we are getting the 60 in the answer. As also you can see, right, the 60 is hiding 10, right? So this 10 is not going to be visible from the bottom view. Okay, so this is the intuition behind solving the problem. I hope you have got the intuition. Now let's see the code. Let's write the code. Okay, before going to the code, I'll request you to subscribe to my channel and like the video. Okay, so let's quickly code. So today I'm going to show the Java code only. Okay, okay. So what we're going to do, so first of all, let's take a map, which is going to be a tree map, right? So tree map, what it does, it keeps the key values in the sorted order. Okay, so we'll have integer comma integer, right? New tree map. Okay. Then what are we going to do? We are going to have a queue. Okay. We are going to have a queue node q equal to new linked list. Okay. We are going to use a queue. Okay. Then what are we going to add in the queue? Q dot add. Q dot add, we are going to add the root. Okay. So before before adding the root, we'll have our horizontal distance, which is going to be 0 for the root, right? And we'll assign, there is a horizontal distance member in the node, right? Which will assign this HDS 0 and we'll add in the queue. Okay. Now we are going to run. We are running here BFS, okay, the BFS of the tree. So that is why we are using the queue, okay, is empty. If run this while loop till queue is not empty, okay, then what we are going to do? We are going to remove this element. Node cur equal to q dot poll, which will remove this element. Okay. Now what we are going to do? Now we are going to check if, first of all, before this, right? What we are going to do is we are going to insert into the map dot add. Okay, map dot add whatever is the current dot horizontal distance, whatever is the current dot horizontal distance, comma current dot data. Okay, so we are adding, right? We are adding to the map the horizontal distance and data. Now we're going to check if current dot left, if it is not null, then what we are going to do? HD equal to current dot HD minus 1. That's what we are going to do, right? Because we are going to the left. When we go to the left, I have already explained. So we are going to decrement the horizontal distance by 1. Okay, and then what we are going to do? We'll assign this. Sorry, we'll assign this root dot HD equal to HD, right? Okay, and we'll add this root dot left. Oh, sorry, not root dot HD. It is going to be root dot left dot HD, right? Okay. Okay. Now what are we going to do? We are going to add this left child into the queue. So what are we going to do? Now, current dot right. So here, when we go to the right, we are going to increment. We are going to increment the horizontal distance by 1, and we'll also add this horizontal distance to the right child of the node, right? To the right child of the horizontal distance, and we'll add a right child. Okay. So in this way, we will have all the horizontal distance, right? And the updated values, okay, in the map. Now, what we're simply going to do? We are going to iterate through the map, right? So map dot entry integer comma integer, right? Entry map dot entry set, we are going to say. So we do this here. Okay, map dot entry set we have here. Then simply what are you going to do? Simply we'll have a result now, a result list of type integer, result equal to new array list. And what we're going to do? Result dot add entry dot get value. So we are adding the node values here, right? And simply we're going to return dot result. So today I'm going to show the Java code only, okay, and not C++ due to time constraint. Okay, so let me compile this. Oh, there's some compile error. What are they saying? Map dot not add, it must be put. Okay. Okay. Now let's submit it. Yeah, the test cases are getting processed. Let's see. Oh, it failed. Why? What happened? Why did it fail? Oh, silly mistake here. It should be current dot left and not root dot left. Here also it should be current dot right. Current dot right, and here also current dot right. So the node current is a current one, right? The node cur. Okay. So let's compile this. Okay. Let's submit it. Okay, the test cases have passed. Okay, thanks for watching. I hope you've got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.